Very good. All right, welcome to Remote Decision Support with CDS Hooks. My name is Dennis Patterson. I'm an Associate Principal Engineer at Cerner with architectural and platform responsibilities for all of our open platform solutions. And I'm a committer to the CDS Hooks specification and one of the maintainers of the public sandbox. So I'm delighted to be here today to talk to you all about the standard. So as great and powerful as smart apps are, there's an inherent challenge that comes with smart apps. So let's walk through an example here. So take the Bilirubin chart app developed by Intermountain Healthcare. And this is useful and helpful to clinicians when the patient is a newborn that it is less than 120 hours old, and their bilirubin results are either not documented or outside of the accepted range. Now, in order for the user to leverage the power of this smart app, first they need to know that the app is available. So they need to know that their healthcare institution has purchased the app, has configured the app. Next, they need to know that the app is relevant. So take these sample criteria. They need to remember in their heads that this is applicable for these set of criteria. And that might seem pretty intuitive for a bilirubin chart app, but extrapolate that problem to a whole host of applications that may be configured at that EHR. And they need to keep track of all the different criterias mentally to know when certain apps are relevant and helpful. And thirdly, the user has to find the app and launch it. So it's not enough to know that it exists somewhere and that it could be used. They need to know where. So which menu bar or sidebar needs to be clicked on, and and how deep has to be clicked to go and find this app. And wouldn't it be great if the system was able to detect that these characteristics are true about this patient and actually recommend the app to the user? Well, that was the problem statement that started the investigation for creating CDS Hooks. That was the initial goal. CDS Hooks, simply put, is a vendor-agnostic remote decision support specification. So vendor-agnostic, meaning it's not proprietary in nature, it is an open standard, and it is an API specification, specifically around, if you have a front-end user application, and then some remote service that's providing clinical decision support that needs to be told about certain actions that are happening in the workflow so that they can return decision support guidance. And CDS Hooks originated from the team behind SMART. It's open source, and it is a published HL7 standard. And so at this point, you might be thinking, doesn't FHIR already define an approach for CDS? And if you have, that's correct. There is a set of FHIR resources focused on clinical reasoning. These are more focused on things like defining decision support rules. You can think of like CQL or establishing measuring standards. But the good news is that these two approaches work in harmony with one another. There is no disunity between them. They are governed by the same HL7 working group, the Clinical Decision Support Working Group. And while the clinical reasoning resources are more focused on modeling decision support within the local FHIR server, CDS Hooks, again, is more focused on an API to talk to some remote web service to obtain decision support. Now, there could be some overlap there. That remote service could leverage clinical reasoning FHIR resources in its approach. And we've seen implementers do this, but they really have two separate focuses. Let's start defining some terms to kind of get acquainted with the standard. So the first one is a CDS service. So that is that remote service that's listening for certain events. It's invoked by the CDS client via a hook. So when you think of CDS client, think of something like an EHR that's aware of the user's actions. And a hook is the event or the trigger. It is that thing that the user has done in the front end. When a CDS service is told about this event, they will evaluate their own logic using FHIR data. So they do have FHIR data at their disposal to understand more about the patient's record, and they'll evaluate their own decision support. I already mentioned that's kind of outside of the spec. And they return their guidance, their suggestions via what the spec calls cards. And we'll dive into all these terms more. But when I say they evaluate their own logic, I really want to make sure you understand this. The CDS service could be very procedural in nature. It could be a series of if-else statements. It could be much more complex using machine learning or neural networks, or it could be a mechanical Turk or a Ouija board. It's really outside of the specification. CDS Hooks is just focused on how does a front-end application communicate, as an API with that remote service for the purposes of clinical decision support. Let's look at some of the example hooks. What are some of the events? These are 3 of the most mature hooks. The specification itself doesn't actually define hooks. It just defines how hooks can be defined. But these 3 have received the most attention. So first we have patient view, which is the action of when a patient's chart is opened. So a service could be listening for that open chart event. And then order select and order sign are different stages of an ordering workflow. So you can imagine as a practitioner is treating a patient, they're going to select one or more orders, right? They're going to search for some kind of orderable, perhaps a medication, and they will select that medication. Now, they may not have entered in all of the dose information or special instructions. They may be still working through the details of that order, but by virtue of selecting that orderable, order select could be triggered. And once they have selected or finished defining what they're going to order, perhaps they've selected some other orderables as well, and they finally are ready to go and place those orders, that's when order sign would be triggered. So let's look at this visually. Imagine again, you have a practitioner treating a patient. They select this med to be placed for the patient. The CDS client or the EHR triggers, we'll say the order select hook because they just selected it. And one or more CDS services are listening for that event. And once they're told about that event, they're going to execute their own rules. They can leverage FHIR data as needed to learn more about the patient. And ultimately, they will return CDS cards, which will be rendered and displayed by the CDS client. Now, those cards can take a number of different forms. It could communicate just information to the user, perhaps a cost of the medication. There could be a suggestion. This is a bit more actionable. You could imagine a button there where an alternate medication is suggested. The user could click that button and the orderable is swapped out on their scratch pad. And thirdly, back to that original use case, the CDS service may recognize that there is a smart app available in the system that could be useful to that practitioner. And so then this card could have again, a link rendered on it. And upon clicking that link, you would open up that smart app. Let's start digging into some of the technical details. Here's an example payload where we have the CDS client that's issuing an HTTP post to a CDS service. It's communicating which hook occurred in the EHR. So in this case, patient view. There's a unique ID for this event, a URL to the FHIR server where more data could be found about this patient, and then contextual information that helps bring light to this event. So since it's patient view, this communicates which user opened the patient's chart and what's the ID of the patient whose chart was opened. These are just some of the required fields. There are others. So the CDS service learns about this event. They execute their own CDS service logic and ultimately return an array of cards. Now those cards, the CDS service can return any number of them. If they decide that they don't have any guidance in this particular circumstance, they would return an empty array of cards. But if they have multiple cards that they want to be displayed to the user, they have the freedom to return multiple cards as well. The CDS client renders each card as it sees fit. So this is a bit different from the world of smart apps, where a smart app developer is very concerned about the look and feel of the application. With CDS hooks, it's a JSON response structure that comes from the service. And so then the CDS client can render that card along with any native decision support and make it indistinguishable if it wishes. Each card must have a concise summary, an indicator denoting the importance of the card, and information on the organization or the data set that's the source of the card's data. So to kind of summarize that, it's what's the gist of the guidance, how important is it, and says who, on what authority is this guidance being shown to me? And again, there's other fields that can be returned, but these are the must-haves, the required fields. And here again, you can see those fields in that card structure. Okay, the card indicator. So a CDS service can return on an individual card an indicator denoting whether it's an info level card, a warning, or critical information. And the CDS client can use this to influence how that card gets rendered to the user. So it may choose to change the coloring or the style of the card, but it also may render in a different part of the front-end application. So you could imagine an informational or a warning card might be displayed in a more passive manner, whereas a critical card might be more of a modal interruptive pop-up. Some common card examples. So information only, in this case, you have a medication that was being placed, but there's some conflict with the genotype of the patient. You could have suggestions. Now, I mentioned before, this could be rendered as a button. This is actually the CDS service returning a FHIR representation of what the user is being suggested to change to. So when it says, switch to this other drug, the service has returned that in FHIR form, and the CDS client would use that and convert that into something that's actionable. And in this case, the medication has a conflict with the patient's race. And so here's an action that you can click to swap things out. And thirdly, that AppLink card. So a recognition of the cardiovascular risk of the patient and a suggestion that they may want to launch this app to dive into that a bit further. Now, when we say information, suggestion, AppLink cards, these are more colloquial terms. There is no card type attribute that kind of makes you, forces you to choose one of these different types. Rather, you can take these different kinds of data and combine them as you see fit. Now here we have an example that has information and suggestion and a link. And you can also note that in the information section, while I said that CDS clients are responsible for rendering the card data, the CDS services can return GitHub flavored Markdown to help influence the look and feel of the textual part of the guidance. So we've talked about how a CDS client communicates with a CDS service, but how does a CDS client discover or know what services are available at a particular endpoint? Well, a CDS service provider would have a base URL. Here we'll say example.com. And if you append the CDS services path segment to that path, you get a discovery endpoint that the CDS service will expose. And that's going to be a whole catalog of all the services that are available at that endpoint, what hooks they're interested in, and how to call them. So here's an example. If the CDS client were to issue an HTTP GET to the discovery endpoint, they would get back a services array. And here we have one example service that's at this endpoint that's interested in the patient view hook. There's a title and description to kind of understand what the functionality is for that CDS service, an ID for the service so that the client knows where it can find the service, and then some prefetch asks for data that it would like sent to it. We'll touch on that later. So kind of correlating these ID fields here, if the discovery endpoint returns that the ID is example service, that means the CDS client knows that it can issue an HTTP post to example.com/CDS services/example service. That's how it knows where that lives. So when a CDS client tells a CDS service about a hook, that CDS service may have proprietary data sources available to it, data sources that make it unique. It's going to specialize in particular areas, but there's also other data available to that service as it executes its decision support. So first, there's the hook context data. We saw an example earlier with patient view, with having the user ID, the patient, right? There's data that's unique to a particular hook that gets sent along with the hook invocation. There's prefetched FHIR data. So we saw in the discovery endpoint, the service can advertise the kinds of data that it needs, and some of that data can be pushed along with the notification of the event sent to the service, as well as there's the opportunity for the CDS service to be able to reach back into the EHR, call the FHIR endpoint, and retrieve any other data that it might need. Let's dive into a couple of these. So for the hook context data, every hook defines its own workflow and context. So you can imagine, as we start getting into these hooks, there's a need for descriptions around when does this hook actually get triggered, what's the unique scenarios, and then what are the core attributes that define this particular event. So that's the data that's specific to a given hook. It's also data that all CDS services using that hook would use. So for example, with patient view, not all CDS services necessarily need the demographics. They will all need the patient ID of the chart that was opened, but rather than forcing everyone to get the demographics, that could be something that could be retrieved or prefetched for the service. So just boil down to the core data elements that define this particular event, and that's what will be in the hook context. And while here we have an example for patient view where you have user, patient, and encounter, you can imagine that the ordering hooks also have order information. The hook context data can be FHIR data or references to FHIR data, but that's not a requirement. It doesn't always have to be that case. Again, looking some at this example, user ID is actually the resource type plus the ID, whereas patient ID is just the raw ID. And the reason for that difference is that with the user ID, you want to include the resource type because there could be different types of users. So in the EHR, you might be more of a, having a practitioner be operating in the EHR. But CDS Hooks does not exclude the possibility of having decision support in a patient portal where a patient is viewing their own data and you could provide guidance or input to them. Prefetch data. This is that data that's FHIR, that's pushed to the service when an event occurs. This is always FHIR data, and it's data specific to a given CDS service. So what I mean by that is you could have multiple services that have unique data requirements, and the CDS client would not take the summation of all of those prefetch requests and pass everything to everybody. Each CDS services would only get the data that's specific to them, the data that they had asked for. CDS clients are not required to honor prefetch requests from CDS services. We'll talk about some reasons why it's beneficial to do so, but it is not mandated. And you'll see that there's still reasons why a CDS service, even with prefetch data, may turn around and still call FHIR to get subsequent data. And prefetch requests show up in that discovery endpoint, and they're expressed as FHIR read or search queries. So for example, you could have patient/context.patient ID. Here, context refers to the hook context. So there's a patient ID field in the hook context for patient view, as well as the order select and order sign. And we're saying, I want the patient resource prefetched for me, sent to me when you tell me about an event. You could also prefetch the metadata to say, tell me what resources are available on your FHIR server so that if I'm going to turn around and call it, I already know what's available. But you could also have, observation queries, condition queries, any kind of FHIR read search query. So why would a CDS client or CDS service want to use prefetch? There's a few different reasons we'll touch on. First, require data that your CDS service always needs. So your CDS service may always check something initially. Now, depending on the state of that data, there might be other data that it doesn't necessarily always need. But if there is some core set of data that it does always need, it would make sense for it to ask for that up front, that it could be pushed to it. For efficiency reasons, CDS clients might be able to consolidate duplicate prefetch queries into fewer optimal requests. So if you have multiple CDS services that need the same data set, it would be more optimal, efficient for the CDS client to be able to push that rather than each individual CDS service having to duplicate and that call to FHIR to go pull that data. And somewhat related, on the performance side of things, the CDS client may have some of this data in cache and memory, or just by virtue of being closer in proximity to the data, might be able to retrieve it with less latency. So that could be another reason to have prefetch. So let's recap the separation of concerns in that overall workflow. You have the CDS client that's responsible for being cognizant of the user workflow, the different scenarios, and the associated hooks, the events, the triggers, and then pulling together the context data that's going to be sent to a CDS service. The CDS service provider is responsible for their own decision support rules, their logic, and for making sure they obtain any additional data that they need. And then lastly, once they return that guidance, the CDS client is responsible for the presentation of that content to the user. And as far as those basic API interactions goes, I encourage you to go out to cdshooks.org. In the navigation sidebar, there is a link to a PDF that looks something like this. It's a summary of the specification. It's meant to be kind of a one-page, one-stop shop if you're going to go through a tutorial that I'll link to later, or if you're doing development. It's not an exhaustive representation of the spec, but it's intended to list out the fields in the requests and the replies involved, give examples, and be kind of a help to you. So we've talked about how CDS clients call and speak to CDS services, but how is this done in a secure manner? Well, the CDS client trusts the CDS service by virtue of it being exposed at a TLS protected endpoint. So the CDS client's going to use all of the standard certificate validation mechanisms that exist to make sure the CDS service is who they say they are. But CDS services also establish trust with CDS clients. So when a CDS client calls a CDS service, it actually authenticates itself via a signed JSON Web Token, or JWT. And we'll take a look at the contents of that in a moment. And then lastly, the CDS client provides a FHIR access token to a CDS service. So mentioned there is the opportunity for a CDS service to call back to FHIR, but it would not make sense in a decision support workflow for the user to be prompted to log in or something like that so that a CDS service can get a token. Rather, the way this works within CDS hooks is that the CDS client pushes a token to the CDS service as part of telling it about an event, a token that's scoped to that service and is scoped to the user that's executing the event. So let's look at that JWT token, the authorization header that would be passed to a CDS service. So if you're not familiar with JWT tokens, there's a brief little overview here. It looks something like this. It's an encoded, not encrypted token. So you could go out to jwt.io, paste this in, and it would decode it for you and help you see the contents. And it consists of 3 separate parts, which are somewhat color-coded if you can make that out. So the first part there is a header. That's going to contain information about the algorithm that was used to sign the token, as well as information about what public key can be used to verify that signature. The last part is the signature itself, so you can ensure that the token is valid, the contents are signed. And then the middle part is the payload, which you can see decoded here. So in that payload, there's an issuer field. So this is going to be a URL to identify the identity of the CDS client. So it might identify the EHR. There's an audience field to identify the intended recipient of this token, the URL to the CDS service. There's a tenant field. So you might know from the token, the issuer is going to communicate perhaps what's the CDS client, what's the EHR, but the tenant communicates, well, what's the healthcare organization that's leveraging that EHR? What's the specific healthcare organization where the user took this action? There's an expiration and issue at time to give a time window when the token is valid. And then lastly, a unique identifier, because these tokens are intended for one-time use. Now, there's a public sandbox that you can go to try some of this out if you're interested in getting your hands dirty at sandbox.cdshooks.org. This is a JavaScript application. It runs entirely in the browser. Your information isn't going to be sent anywhere. And this serves as a mock EHR. You can connect it to any FHIR server or CDS service that is accessible from your browser. So you could be running those locally if you wish. And as you can see, there's a patient view tab and an RX view tab. Patient view, you probably guess, allows you to test the patient view hook, whereas RX view tab maps more to the order select hook, but in the context of meds. And so here, we have the CDS Hook sandbox wired up to some local services or some services with some example cards pulled from those services. The developer panel is expandable and allows you to dig into a particular service. What is the body of the request that was sent to that service? What does the sandbox think that it received from your service, and kind of aid you in development? These are some logos for some of the CDS clients that have showed up at HL7 Connectathons to implement the spec and try it out, as well as a sampling of some of the CDS services that have also implemented from their perspective. And so I show this not to be exhaustive, but to give you an idea of the type of interest as well as attention that the specification has received in terms of making sure that it meets a variety of use cases and it gets vetted. In the US, the Argonaut project, which exists for accelerating adoption of open standards, have shown love and attention to CDS hooks. So back in 2017, they were focused on the use case of pushing smart apps. That was that initial use case I touched on earlier on. The same year, they funded an external security assessment and threat model using the same security company that did those for the SMART spec. And then last year, Argonaut was focused on the use case of pushing appropriate radiology ordering via a CDS service. So this is a US specific use case where you place a radiology order for a particular condition, and a remote CDS service returns a score that can get automatically stamped on that order if it's able to make a determination. Publication-wise, the 1.0 spec was published last April 2019. Since then, we've been validating and maturing hooks. So patient view has been validated. The ordering-based hook would be up next. We've also recently validated the 1.1 specification. So, and I can touch on some of what's in that here. So 1.1 contains system-only actions. So I mentioned just a moment ago the idea of automatically stamping a score. Now, this is something that you might not necessarily interrupt the provider to get their approval for. It's something that's not going to be necessarily clinically unsafe. A simple score value could be automatically applied to an order. And so there's going to be, depending on the arrangement between the CDS client and the CDS service, some set of clinically safe actions that could potentially be automatically applied. Enhanced suggestion handling. So today, cards that come back from CDS services that have suggestions, you can think of them kind of as a radio button style suggestion. So if there are multiple suggestions, the user has to choose one of them. But one of the things that 1.1 allows for is breaking apart those suggestions a bit. Maybe if your use case supports that, to be a bit more modular. You can imagine transitioning from radio buttons to checkboxes, where the user could pick and choose which parts they want to accept, along with allowing a CDS service to indicate that one or more of those is a recommended suggestion. So that could allow the CDS client to auto check that value. And then lastly, capturing decisions. So there is a related spec, the Smart Web Messaging spec, that I'm not going to get into, but ties in nicely to the overall workflow. But the other part of capturing decisions is giving a bit more of a feedback loop and telling CDS services how a user interacted with their cards. So for example, a CDS service could return some override reasons why a user might choose not to accept the guidance that could be displayed to the user alongside any native override reasons. And then, like I mentioned within the 1.0 spec, the CDS service is unaware of card interactions. So by exposing a feedback endpoint for a particular service, It allows communication of which suggestions were accepted, was a card overridden and why, and a CDS service can use that information to refine their algorithms or otherwise incorporate that information into the way that they return decision support. The latest and greatest specification is out on cdshooks.org, whereas all the releases are on HL7's website. Here's again a link to the public sandbox, sandbox.cdshooks.org. All of CDS Hooks, the specification and the sandbox, are open source. So I also invite you to go out and take a look at issues that are floating around or suggest your own. I encourage you all to get involved to help us mature the spec, take it to the next level, bring it to use cases that we haven't dealt with yet, as well as show some love and TLC to our public sandbox. If you are technically inclined and you want to get your hands dirty, you can go out to this URL and check out the CDS services tutorial. So there's a corresponding wiki that'll walk you through this, but if you check out this project from GitHub, you'll have some CDS services out of the box that you can run locally for patient view and order select, and wire those up to the public sandbox. They work out of the box, and it'll walk you through how that all works and give you some ideas for further enhancements. All these slides are open source. They're out on my GitHub, so github.com/Dennis Patterson, and should be able to find them there, as well as they should be made available as part of the conference. During DevDays, you can find me on the Whova app. I'm also out on Zulip if you have other follow-up questions that we aren't able to get to here. And that's all I have for you. So thank you very much. I do see some questions that have trickled in here. So I'll try to take a look at some of those. All right, the first question that I see is, what are the most frequent use cases for using CDS hooks? Great question. It really kind of depends on the types of decision support that you're trying to offer. I did mention that the most frequently used hooks are patient view, order select, and order sign. But then the types of guidance that can be returned as a result of that is pretty limitless. Now, I mean, you can think of an ordering-based workflow. You're going to have suggestions to swap out different orders, recognition of again, smart apps that could be applicable and helpful to the user. So I guess it's kind of challenging to answer that question because there are so many different use cases that could be possible. CDS Hooks just enables those use cases to come forward by providing an API for a CDS client to tell a CDS service what's going on in the front end. Will a CDS service typically generate the aggregates on the fly, or is this predetermined? So example, percentage of providers prescribing the medication. Generate the aggregates on the fly. So I'm not sure that I 100% grasp the question, but the CDS service, as it learns about events, will know, I mean, it's going to know the specific EHRs or CDS clients where those events have occurred. If that tenant field is populated, they will know the individual healthcare institutions. And because that user ID is in all the hook context data, they will be able to keep track of who is doing what where. And then with the feedback loop, they could also incorporate just knowledge of where are these suggestions being accepted, where are they being declined, and they could generate some statistics which could then show back up in CDS cards that are rendered at those different locations. So hopefully that kind of answers the question. So they would kind of collect some of those stats as time allows, and then be able to funnel that back to the front end as additional notifications of events occur. What existing standard hooks are currently being tested, and will more standard hooks be added in the future? Absolutely, more standard hooks can be added in the future. Again, the CDS hook specification does not define hooks, it just defines how hooks can be defined. So it basically creates that framework so that if there is community need industry need for particular hooks, those can be defined. They need to obtain broad adoption, or maybe not broad adoption, but start out with adoption across different EHRs in order to be useful. So the EHRs have to support them as well. The standard hooks I mentioned are patient view, which has been balloted, and then order select and order sign will be the next ones that we intend to ballot. But if you go out to our GitHub, you can see some of the other hooks that have kind of been proposed. They're maybe not quite at the point where they're ready to be balloted yet, but I know for sure that there are other hooks that folks are experimenting with. Let's see. Is there some asynchronous specified or allowed within CDS when dealing with events and hooks? Great question. Right now, CDS hooks is focused on synchronous workflows, so direct user events, such as the ones that I've already mentioned. There has been talk about asynchronous events. Part of the challenge there is that CDS hooks is focused on decision support. So when you have an asynchronous event where a user isn't necessarily active, kind of working through, okay, if this event happens, so something gets written, who should the guidance be shown to, right? Because it's not necessarily an individual user that is there actively looking at the chart or is placing a med or whatever other orderable. It's something else has happened, and as a result, yeah, there may be some guidance, but who does it get shown to? And if it's critical, how do you ensure that it's shown, immediately? So there's some things to work through there. Subscriptions always comes to mind here too, because the FHIR subscriptions is very much focused on listening for changes in data sets and being able to notify service endpoints when those events occurred. And from there, the service may have different things that they do with that. But I guess to circle back around here, asynchronous isn't something that CDS Hooks is currently focused on, but it's something that we'd be interested in talking about further. Any comments on patients protection? Patients data protection. So Tony can follow up if I don't quite hit the nail on the head here, but the token that gets sent to a CDS service, or even the data that's sent to a CDS service, does not exceed what the user would be able to access. So there would be privileges already enabled in that EHR, in that system, that the user can only access certain things as it is, and that user is actively, synchronously engaged in treating that patient. So the CDS service only gets access to what that user gets access to. And it would be an arrangement between the CDS client and the CDS service to validate and onboard that CDS service to a system. There would be contractual obligations and agreements there to ensure that that service is going to use that data in an appropriate fashion, just as you would have today with a smart app that's getting access to some of the patient's data. And sorry, the questions are kind of shuffling around, so I'm trying to make sure I haven't missed any of them. The next one I see is, what's the difference between CDS hooks and FHIR custom or extended operation? So one thing I'll note on here is that something I mentioned early on is there are clinical reasoning FHIR resources. So there's FHIR resources focused on the various aspects of the problem of decision support. And so, focused on modeling decision support and perhaps some of the rules around decision support. CDS Hooks is more focused on just establishing an API to talk to a service. Now that service could be hosted on the internet. It could be hosted locally, local to the EHR. It's really kind of outside of the spec. It just establishes that API. And so it's not focused directly on engaging with FHIR more directly. It's just establishing an API. No matter how you implement that service under the covers, how do you tell in a synchronous manner about a particular event and receive some decision support guidance that can then actively be displayed to the user? So hopefully I see if there's a follow-up. Okay, sounds like I touched on that well enough. I do not remember tenant as RFC JOT standard. Is it is it added attribute for CDS. So the CDS hooks specification gets to define the payload. And so, yeah, it is added as a first class attribute within that payload body. So you can feel free to ping me offline. I'd be glad to kind of dig into that some more. Let's see. I am not seeing other questions. Last call for questions. I'd be glad to entertain them. I do appreciate you all coming out, listening to me walk through the standard. I'm always encouraged by the flurry of questions that comes in, because there's usually, it communicates that there's interest in the standard. There's recognition of potential in the standard, and folks are just interested in wanting to know more, wanting to see, how can we use this to conquer problems within healthcare. But I'm not seeing any more questions. So with that, we'll kind of wrap things up. Thank you all for your time.